from the particulars pulled away at 7 feet per second. That'll show up later. That's dx dt is what they're giving me. I have the Pythagorean theorem set up here, and what I want to do is take the derivative. So that's going to be 2x dx dt plus 2y dy dt. And the derivative of 25 squared is 0 with respect to time. So the 2's will simplify, and my derivative will be x dx dt equals, now I'd subtract that from both sides, so that would give me equals negative y dy dt. When the bottom is 24 feet, so now I'm going to use the Pythagorean theorem to find out what the y value equals. So Pythagorean theorem, I'm going to plug in the 24 and the 25. It would give me the hypotenuse squared minus the leg squared, 24. So y value is 7. So here we go. X is 24. Dx dt is 7. Equals y, negative 7. Well, that's going to be nice. That's going to cancel out. Times dy dt. And that's what I'm looking for, is the dy dt. So when I divide both sides by negative 7, I'm just going to get negative 24. Negative 24. And in this case, it's going to be feet per second. Number 12, I already have the formula laid out. But what I need to do is eliminate the radius r. So I'm going to set up a ratio over here. R over h equals 2 over 6. Well, 2 over 6, that would simplify to 1 over 3. So this is just going to give me r equals h over 3. I'm going to plug that r in up there. So that's going to give me volume equals pi over 3 times r squared times h, and r was h over 3. Notice now I'm going to square the h. H squared times h is h cubed. So I'm still working on the normal formula, not even the derivative yet. So that's going to give me h squared times h, which is h cubed, over 3 squared, which is 9. Now, I'm being very patient. I don't want to multiply those because I notice when I do take the derivative, the 3's are going to cancel out using the power rule. So the derivative is dv dt equals, the 3's going to cancel out. So that's going to give me pi over 9 h squared. I have to subtract 1 from the exponent. dh dt. And that's my derivative. So let me write that down real quick. My derivative, dv dt, is equal to pi h squared over 9 dh dt. Now what I want to do is plug in any values given to me up in the problem. dv dt, the water flows in, is 5, so dv dt is 5. And that's going to equal pi over 9 h when the water is 3 meters deep, so that's going to be 3 squared. 3 squared is times 9, and that's times dh dt. Whoops, I should have put dh dt there. Got a little excited. dh dt. And notice the 9's will simplify, and my final answer, when I divide both sides by pi, is going to give me 5 over pi equals dh dt. So my answer is 5 over pi. Again, this is going to be meters per minute. Meters per minute. Walking shadow, this one's 2 parts. The light casts a shadow when I'm in, and he's walking away. So x is changing, and I think they give me dx dt. And walking away at a rate of 6 feet per second, so dx dt equals 6. And it has nothing to do with this here height of the guy being 6. So 6 over y is going to be my left side of the proportion, and 18 over x plus y is the right side of the proportion. Now I'm going to cross multiply, and that's going to give me 18y equals 6x plus 6y. A little bit more simplification, I'm going to subtract 6y from both sides. I think 18 minus 6 is 12y equals 6x. I'm going to divide both sides by 12, and that's going to give me y equals 1/2 x. Now I'm going to take the derivative of that. So the derivative of y with respect to time is dy dt. And that's going to equal 1/2 dx dt. Now I already have it highlighted that dx dt is 6. And that's all I need to plug in here. And they want to know how fast the shadow is lengthening, and that's y. So they're looking for dy dt over here. So I'm going to plug in that 6 for dx dt. So my dy dt is going to equal 1/2 of 6, which is going to give me 3 feet per second. Now they want to know at what rate is the tip of the shadow moving. So the tip of the shadow, this is dy dt, but it also has dx dt added to that. So basically, to do this portion of the second part of the problem, all you do is dx dt plus dy dt. That's all you have to do. And dx dt was given as 6, and dy dt we solved to be 3. So it's basically just going to be 6 plus 3. So it's moving away. The tip is moving away at 9 feet per second. For number 14, it gives me that its altitude is 10, so I wrote that down there. It wants me to write theta as a function of x, so I have opposite and adjacent, so I'm going to use the tangent ratio. So tangent of theta equals 10 over x. So then I'm going to write that as theta. I'm going to take the arctan of both sides. So when I arctan the left side, they cancel out, and I arctan the right side. That gives me theta equals arctan of 10 over x. Now for this part, I want to find the derivative, d theta dt. So I'm going to go ahead and do that. And the derivative of theta is d theta dt. And then, I don't know if you remember this, but the derivative of tangent is just 1 over 1 plus x squared. But I have to use the chain rule because it's not just an x there. So that 10 over x is going to go inside the parentheses. And now I actually have to find the derivative of 10 over x. So I'm going to rewrite that as 10x to the negative 1 when I bring that upstairs. And then the power rule is going to give me negative 10x to the negative 2. I'm going to send them back downstairs. So the top is going to give me negative 10 over x squared. I can't forget to multiply it by dx dt. Now I'm going to start plugging in values for what it gave me. It gave me x equals 20, so I'm going to plug a 20 in there, a 20 in there. It gives me dx dt equals negative 800. So let me see here, negative 10 over 20 squared, so that's going to be negative 10 over 400, all over 1 plus, and notice when I put the 20 in for x, that's going to give me 1 half, so I'm going to write it as 0.5 squared times the negative 800 from the speed of the plane. This is going to simplify down a little bit further. Notice negative times negative is positive. 800 divided by 400 is 2. So my calculator key in is going to be 2 times 10, which is 20 over 1 plus 0.5 squared. You'd like to use that. So it's going to be 20 over 1 plus 0.5 squared, and that's 16. So this angle is going upwards at a rate of 16 radians per... Does it tell me anywhere? Per hour. The key to most of these is getting a diagram going. So I have my boat out at sea. The height of the winch that's pulling the boat in is 9. And it's going inward at a rate of 18. So that's going to be my dx dt. And remember, if it's going towards the origin, that would probably be negative 18. And they want to know how fast the rope is going in. Notice it's going towards the person pulling the rope. So that's probably going to be negative dz dt. For these problems, you don't want to plug that 9 in. I mean, you don't want to plug that 41 in until the end. So I'm going to take the derivative. This 9 is constant. That 41 just so happens to happen at an instant in time. The 9 is going to be continuous. So I'm going to take the derivative of this, which is 2x dx dt plus 0 equals 2z dz dt. I know I can cancel out the 2's, so that's what I want to do. I want to rewrite my derivative over here. So I have x dx dt equals 2, oops, I don't need the 2, equals y, z dz dt. Now, it doesn't tell me what x is. It does tell me what z is. The rope is 41. So now I have to use Pythagorean theorem to find the third side. So it's going to be the square root of 41 squared minus 9 squared. 40. This base is 40. So x equals 40. Dx dt equals negative 18. And that's going to equal z, which is 41. dz dt. And that's what we're looking for. dz dt. I'm going to divide both sides by 41. And that's probably going to be my answer. I don't know if I can simplify it or not. So I'm just going to plug it into the calculator and see what happens. So 40 times negative 18 all over 41. I think that's fine. And it's just going to give me negative 720 over 41 as a decimal to 3 places. That would be negative 17.561. Negative 17.561. Let's see what this is. It's feet per second. Thank you.